So let us get started here today with this one here. And it says right now basic derivatives day 2, but that's where we're just going to start off with. There it is. Okay. So now that you know how to find the derivatives, using the rules, a problem like this one is not a big deal. It would have been a big deal a while back, but we used to do a trick where somebody would be absent on the day when we'd learn how to do this. We'd come in, we'd give a quiz like this one. Everybody would be finished in 5 seconds, and the other person would be struggling along with the f of x plus delta x to the 4th minus 3x plus delta x, and trying to do it the other way that they hadn't learned yet, that they still were familiar with, and everyone else would just write, oh, y prime, well, it's 20x cubed minus 9x squared plus 4x plus 153, and we'd all have a jolly laugh, and we'd let the person in on it, and then we'd move on to the next topic, which is equations of tangent lines. Okay, so there's a view taken from my front porch. Tangent lines everywhere. Right there, there's a nice little curve. There's the tangent line. There's the lawn that I mowed. So this is a couple summers ago, but still, it's just as lovely. So in order to find the equation of a tangent line, well, to find the equation of any line, we need to know the slope. We need to know a point on the line. So we need to find a slope, and we need to find a point on the line. So we can write our equation in point-slope form. It seems a little choppy for a second. I got interrupted by a knock on the door, and then I went to find it, now I'm back. So hopefully I'll be able to splice this together, and you won't even notice, and you'll wonder what I'm talking about. So we want to find the equation of a line that's tangent to this when x is equal to 2. Okay? So to find the equation of a line tangent to this, we need to know the slope, and we need to know the slope of the tangent line, and the slope of the tangent line is also known as derivative. So we find the derivative. Yeah, there we go. So the derivative, real quick, using our rules. Derivative of 3x squared is 6x, derivative of 2x is 2, derivative of a constant is nothing. So the derivative, the slope of the tangent line, is 6x plus 2. We're going to evaluate that when x is equal to 2. 6 times 2 is 12, 12 plus 2 is 14. So the slope of the tangent line at this particular point is 14. So I get happily out my point-slope equation, all right, like so. I know what m is 14. I know an x-coordinate, 2. The only thing I don't know is a y-coordinate. And I can get that pretty quickly by evaluating my original function when x equals 2. So I take this over here, 3 times 2 squared plus 2 times 2 plus 5. 2 squared is 4, 3 times 4 is 12. 12 plus 4 is 16, plus 5 equals 21. So I'm just going to write y minus 21 equals 14, x minus 2. So that is the equation of the line tangent to that one when x equals 2. Okay. So that's it right there. That's the equation. That's the line right there. Boom, there's 2. There's the tangent line. Just barely touches it. And you see it's pretty steep. It's got a slope of, what, 14? So it's a pretty darn steep line, going way up there pretty quickly. Okay, so that's how we find the equation of a tangent line. Now, we want to find the location of a horizontal tangent line. And the first question is, what is the slope of a horizontal line? Am I blocking my face with this? Oh, no. The slope of a horizontal line is 0. The slope of the tangent line is the derivative. So really what this thing is asking, if I ask for the location of a horizontal tangent line for this thing, I'm asking, where is the derivative equal to 0? How do I get a horizontal tangent line? So, first thing we need to do is find yon derivative. Y primed equals 3x squared minus 12x plus 9. There's the derivative. We want to know where that derivative is equal to 0. We want to know where the slope of the tangent line, the derivative, is equal to 0. Okay, so we could quadratic formularize this, but I'm noticing that everything, conveniently enough, is divisible by 3. So I'm going to pull a 3 out and make this that. Okay, And then, lo and behold, I can factor this. You can factor this. We can all factor this. X minus 1, x minus 3 equals 0. I'm going to neglect the 3 because if I divide 0 by 3, I still get 0. So this gives me a horizontal tangent line when x is equal to 1 and when x is equal to 3. I can find the exact location by plugging back in there, find the x and the y coordinates of them if I wanted to. Let's just look at what that x cubed minus 6x squared plus 9x looks like. It looks like this. And by golly, if I was a guessing man, a man that could get a line to come up, I would guess, oops, well, I'm a little low, but I would guess I have a horizontal tangent line right there, and I have another one right there. And x equals 1, and x equals 3. There you have it, I think. Let's see. What else we got? Back to that. That's it. That's all. Okay. So just a little extension, a couple of applications of the derivative. Use it to find the equations of tangent lines. We also will use it to find the equation of normal lines, and a normal line is the only thing different about a normal line. Okay, normal means perpendicular. It's just a little fancy extra math word for perpendicular. So if I go back to that, I don't know what I'm spelling. It says perpendicular. So if I go back to normal perpendicular, if I go back to that one where we found the slope was 14, the slope of the normal line would be negative 114. So if we're looking for slopes of tangent lines and normal lines, it's just perpendicular and tangent. So that's the only extra piece that I will quickly throw in there. And then I shall be done. Don't worry about what that says as a quiz. We don't do quizzes. I don't think we do. Weekly assessment. So thanks for watching. I hope you enjoyed the festivities. We'll see how this turns out when I edit it. It'll be just smooth as anything, and we'll talk to you soon. Bye now.